Welcome everyone. Right, today I'm going to do something very silly, and I'm going to use the compiler to generate music. So at compile time, with template music programming, the new TMP. Or if you really want to, it could be called Contexpr composition. So how to make a synthesizer 101. You need an oscillator, you need an envelope generator, you need some notes and an instrument that kind of plays those notes. You need a sequencer, because otherwise writing all the notes in by hand is very tedious, as you might remember from such things as BASIC in the good old days. And you need a WAV file generator. So we've got all of that at compile time at this location. I'm not going to go too heavily into the code because there's a fair bit of it, but we're going to have some fun. So oscillator, I'm just going to do a simple sine oscillator. So stood sine, currently not Contexpr enabled, but it works in GCC, so it's all good. An envelope, if you haven't seen this before, it just sort of gives some shape to the note. So there's normally an attack, which is the sharp spike that goes up to a higher volume, a decay down to a normal level, a sustained period while you hold the key down, and then a release period, right? And then it just fades to 0. So yeah, it gives you the kick when you hit a key, yeah. So notes define the frequency, obviously, and the duration, and an instrument knows how to play those notes. It knows what its settings are, and so you just send it the different frequencies to play. So in this case, we have a sample rate because we need to know what our wave sample is going to be, because that determines our timing. We have our sine synthesizer here. That should be an underscore there. We've got an envelope definition, so that's our rise time, attack level in dBFS. So if you're audio people, you know what that is. If you're not, 0 is loudest. Negative is quieter. We decay for 0.2 of a second down to half power level, and then the decay at the end is 5 milliseconds. And we have an overall volume of -1 just to kind of keep it down so we don't clip. And then we can play a note. We can say, I want to play A4 at 0.1 of a second into the thing, into the song, and for half a second, or 1.5 seconds. But that's a bit painful. So we want a sequencer, and a sequencer takes a list of notes and sends them to the instrument at the right time. So I have a sequencer. I calculate the length of the music from this music score source here, which we'll see in a second. I tell the sequencer to parse that, and we go off and render it into our wave renderer, and then output that into the executable. So here's our music notation. I think you can probably understand it. You've got our notes here. Time goes this way. These are our bars. These are notes. So the longer they're held down, the longer the note. Put it all together to render it. We put it into a section called wave file. It's constant it, so it's guaranteed to be done at compile time. We render our song, and we compile. And then we extract our wave file. Obviously, we need to turn the Contexpr operation limit up to 11, and off we go. So hopefully this works. That's the wrong button. Okay, so nothing up my sleeve, no wave file there. We build, now this takes a few seconds. So compile times are a little bit long, but the benefit is, of course, you can build your album in CI, and you can run your unit tests and everything like that. It takes about 16 seconds for this song. There we go. And if I can type, oh my goodness. Yes, that is the most elaborate Rickroll today. Thank you, ladies and gentlemen.
Thank you.